Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 6 of the January daily LeetCode challenge, and we again have a medium question in front of us. And as you might be knowing, if you have seen my videos previously, this is going to be a prefixSum question again. From the last few days, we are getting questions on prefixSum, and this is again a very good question on prefixSum, because here you will never know that, yeah, by reading this question, you will never get to know that okay, we have to apply prefixSum here, but the optimal solution will depend on whether you are applying prefixSum or not. Okay, so this is one of the application of prefixum, and it's a very good question. The quality is very good. If you are someone who has done a good number of questions, you can give it a try, and this will be a good test for you. If you are a beginner, then you have to learn first prefixum, what it is, see some applications of it, and then come to this question, because this is slightly on the harder side. That is what I would say. But again, I'm not talking about the brute force approach. Using the brute force, you can get the answer, I guess, easily in the O of n square solution. But for optimal solution, that is O of n solution, you will need some practice. Okay, that is what I just wanted to say before starting this question. If you want to see the number of acceptance rates, it is really good acceptance rate at around 90%, so it's really good. But yeah, I will say this question is very good in terms of the complexity. Now let us go to the question. It's 1769, minimum number of operations to move all box to each box. Okay, so here if you see, you are just given a binary string called boxes. In this, you see the length is going to be n, and each of the values are going to be between 0 and 1. That's why it's a binary string. Okay, now that's why they mentioned you have n boxes each. So you are given binary string boxes of length n, where boxes of I is 0 if the ith box is empty, and 1 if the box contains one ball. Okay, so either it could have 0 balls initially, or it could have one ball initially. In one operation, you can move the one ball from a box to an adjacent box. Box of I is adjacent to box of J if they are doing this. Okay, what they're trying to tell you is that adjacent means either it could be adjacent to the left or adjacent to the right. Okay, that is what adjacent basically means, a neighbor. Okay, if two cells are neighbor of each other, then you can call them adjacent of each other. Okay, so no need to go for these things. They are just given to confuse you. Okay, as simple as that. These things doesn't hold any real significance. They're according to me. Note that after doing so, there may be more than one ball in some boxes. Okay, so that's what they're trying to tell you. For example, see this. If I move the first ball toward the right, it will come here. Okay, so now in the index number 1, I will have two balls. That is what they're trying to tell you. Okay, return an array answer of size n, where answer of I is the minimum number of operations needed to move all the balls to the ith box. Okay, so idea here is, see here, this is also I, this is also I. So what they are trying to tell you is that what you have to do is, you have to move all the boxes to each of the I boxes, and for each of those cases you have to tell what is the minimum number of operations needed. Okay, each answer of I is calculated using the initial state of the boxes. So let us see each question one by one, that is each case one by one. So if you see the example number 1, so what is happening is here. So idea here is, I have to move all the other balls to index number 0. So which all balls I need to move? See, this current ball is already at index number 0. So for this, I don't need any operation. Okay. So if you see what is the definition of operation, operation basically means that to move a particular ball to its adjacent neighbor, you will need one operation. Okay, that is the definition of operation. Now let us see this. So what is the case one? Case one is that we have to move all the balls to the index number 0. So if you see, this is the only ball which is left to be moved. Okay. So now this has to be moved to index number 0. Since it is adjacent to the index number 0, so this will be moved to index number 0 in one operation. Okay. So after this one operation, I will have both the balls in index number 0. One is already there, and the other one could be brought in using one operation. For that reason, the answer is going to be 1. Okay. Now let us see the other case. That is, we need to bring all the balls to index number 1. Okay. So already one ball is there in index number 1. You have to bring the other ball to index number 1. So if you see what is the other ball is this one. This has to be brought to index number 1. So there is only one ball, and it has to be moved to its adjacent position. So the operation is going to be 1. So again, the for the value for this is going to be 1. Okay. Now comes the most interesting part. See here. Here, currently we have to move all the balls to index number 2. Okay. By default, there are no balls as such in index number 2. That is, all the balls will have to be moved. Okay. There is no ball already present there. So now for each of the balls, we'll have to do some operations. So see here, case by case. If you talk about this particular ball, this, since it is adjacent to index number 2, so this could be moved in one operation. Okay. So this ball will take one operation. Now talking about this, see here, this ball is going to take two operations. Okay, because first it has to move to index number 1, and then it has to move to index number 2. So this ball is going to take two operations, this ball is going to take one operation. So 2 plus 1, 3. Total 3 operations will be needed to move all the balls to index number 2. Okay, so each of these is going to tell you how many number of operations are needed to bring all the balls to ith index. Okay, so answer of I is going to tell you the number of operations needed to bring the minimum number of operations needed to bring all the balls to index I. Okay, so that is the basic definition of this particular question. Okay, so each answer is calculated. Okay, yeah, return an answer, okay, of size and where answer is the minimum number of operations needed to move all the balls to the ith box. Okay, so I hope the example one is clear to you. Now let's see what we can do. So today I will be directly showing you what I'm going to do here. So see, because this question is, not that easy for you to understand, first of all, because you have to go through examples, and I will, directly tell you what I'm doing, because I don't want to take much of your time, because see, this solution needs very, clear cut idea of what a prefixum is. Only if you know that, you will be able to solve this kind of questions. Okay, so see here what I'm going to do. In short, what I'm going to tell you is that the sum of this and this is going to give you the answer. Okay, if you see, if you add this, that is 0 plus 1 is going to give you 1. Okay, similarly similarly 1 plus 0 is going to give you 1, which is already there, and similarly 3 plus 0 is going to give you 3, okay, which is here. So the sum of the arrays, that is values of this and this, is going to give you the answer. But before that, I will going to show how these are coming. Now, what is the first box? Boxes count left. Okay, so what it is telling you is this: from left we are going to start counting the boxes, and this is kind of going to be prefix sum. Okay, for example, here we are going to start with 1. Okay, then when I move to this index, I will be adding all the boxes that we have seen. That is, idea here is, once I see a box, I'm going to pick, sorry, okay, once I see a box, I'm going to pick all the balls in that box and then move to the next index towards the right. Okay, something like that I'm going to do. Okay, you have to imagine it like that. So here we had one balls, so I picked it up. Okay, so here I'm writing 1. Next, I came here already one ball is there, and I am having one ball from previous index. Okay, so here total number of balls are going to be 2. Okay, next we came here none of the no balls is present by default, so the balls which we are having is from previous indexes. So how many balls we are having? We are having 2 balls. Okay, we'll have to interpret it like this. Okay, we are going to collect all the balls in a prefix some way from left towards right. Okay, so I hope you got it what it is. Okay, so you will have to be very clear here. Only then you will be able to understand. Okay, here each index will tell me how many balls are going to come in this particular index from left. Okay, I hope you are getting what I'm trying to say. How many balls are going to come to this particular index from left? Okay, so if you talk about index number 2, here 2 balls are going to come. Okay, so I'm writing 2 here. Now, what is prefix sum of left? Okay, so prefix sum of left is going to tell me, see here, first of all, the zeroth index is always going to be 0. Next, so here it is going to tell me, now try to understand this part. Okay, what is happening here? See, prefix sum of I is going to tell me the total number of operations needed to bring all the balls towards the left of it to the current index. Okay, that is, when I'm talking about index number 1, that is, I want all the balls towards the left of index number 1 to be brought to index number 1. For that, how many operations will be needed? The prefix sum of this prefix sum left of I is going to tell you that. Okay, so from left I'm talking about. Okay, then we are going to see about right and so on, right, all that. Now, please be very clear in this. So what we are going to do, see here, there is one ball which has to be brought to the right. Okay, there is only one ball which has to be brought to the right. So this ball will take one operation, and prior to that we did not have any other balls, so we don't have anything else carried over. So 0 plus 1 is going to be 1. Now see it very carefully. Now I'm going to show how this 3 is coming. See here. So we are having 2 balls to be moved to this index. That is, from index number 1, I am going to move 2 balls to index number 3. Sorry, yeah, from index number 1 to index number 2, I'm going to move 2 balls. Okay, so this is the 2. Okay, see here. So here I'm going to have 2 balls. Okay, so these 2 balls will be moved to index, so one index. Okay, so each one of these balls is going to take one operation. So 2, I got it right. Next, now one among these 2, okay, came from a previous index. So to bring that to the current index, I need one operation. Okay, so see this part, this 2 plus this one, if you add, you are going to get this 3. Okay, I hope you're understanding. See, the one index prior to that, that is, I am talking about index number 2. So we have to bring all the balls from index number 1 to index number 2. Okay, so there are 2 balls in there are 2 balls in index number 2. Okay, just a second. There are 2 balls in index number 1 that has to be brought to index number 2. Okay, so each one of this ball will going to take one operation. Okay, so these two, each one of them is going to take one operation. So 1 plus 1 2, so 2 operations we are done. Now the thing here is, one of these balls which we already counted is actually coming from even previous index, so that also we'll have to calculate. Okay, that is to bring it, for example, this particular one has to come to this index, right? For that we need to add the calculation. For that, this is going to be the operation. Okay, so this 2 plus this one is going to give me 3. So in total, if I see, that is, even in order to bring all the balls from the left of index number 2 till index number 2, I need 3 operations. Okay, as simple as that. Now the same thing here for the right. So this is the count of boxes from the right. That is, I'm going to start from the right and go towards the left. Okay, so here it is 0. I will write 0 as it is. Then Here there is 1. I will add 1 as it is. Next, now this 1 will be picked from here and will be taken to the next index toward the left. Okay, so here I'm going to have two boxes now. Okay, similarly the prefix sum toward the right. Okay, here again I'm going to start from right toward the left. See here, I will see always the last index will be 0. That is always this part will be 0 here, and always this part will be 0 here. Okay, now this is 0. Now please pay attention here. Now for this, okay, for this again here there is no ball towards the right, so which I can bring. So again this will remain 0. Okay, now pay attention. Now I'm talking about this. Okay, so see here, there is only one ball. I'm talking about index number 0. Okay, now it what says right, there is only one ball to be brought. Okay, there is only one ball to be brought to this index. Okay, so this will take one operation. Okay, and since this ball is already present here itself, that is this origination of this ball is from its neighbor only, so I don't have to spend any other operation, so it is 0. So 1 plus 0 is going to give me 1, which is going to be here. Okay, now if you see the answer, see here, I am going to add these things with these things. Okay, index wise, that is if you see 3 plus 0 is going to give me the answer here 3. Okay, similarly 1 plus 0 is going to give me the answer here 1. Okay, and similarly 0 plus 1 is going to give you the answer here 1. Okay, let me show you some other example, because example number 2 is very good one. See here, index, okay, example number 2. Yeah, if you see this part, if you see all the sums here, okay, and all the sums here, if you add them, you are going to get this. Okay, let us see each one. Okay, I'm going to add 11 plus 0. I'm going to add 11 here. Okay, so what is the idea here? Idea here is I will try to see, okay, how many balls can be brought from the left and how many balls can be brought from the right. Okay, because ideally, let us say we are in the middle of somewhere. Okay, for example, see here, let us say I am here, so all the balls which are there towards the left, I will bring it to this index, and all the balls which are there towards the right of this, I will bring them back. Okay, so this is the idea. So while bringing them from the left, I will use this, and to bringing them, that is bring the balls from the right towards the current index, I am going to use this. Okay, as simple as that. So if you see here, yeah, let us take this part. Okay, 1 plus 3 is going to give you 4. Okay, so here how this is 4 is coming. So idea here is one ball is coming from left and three balls are going to come from right. Okay, as simple as that. So this is about this particular index. Okay, yeah, this particular index. Okay, so these are basically operations. Okay, three operations are needed to bring all the balls from the right. Okay, see, if you see here this part, for I'm talking about this index, so these two balls can be brought toward the index number, this particular index, in three operations. And similarly here, to bring all the balls to this index from the left, I'm going to take one operation. So this is the ball. In order to bring this to this particular 0, I'm going to take one operation. So that's why you have to add 3 plus 1, which is going to give you 4. Okay, you have to add 4 as it is, right? So yeah, this is how you're getting this particular answer. So okay, let me now show you the solution, because till now I have spent a lot of time on the explanation itself. Now let me show the solution. So yeah, like as you can see, like we have to create so many arrays, but yeah, remember this is I'm just trying to teach you the idea. Remember, this question can also be solved in constant space complexity. That is also possible. I will tell you how, but just be with me. I'm taking you from step by step approach. Okay, so we are creating a prefix sum left array. Here all the values are going to be 0 and the length is going to be n. Okay, the same is the case for other three arrays. Okay, here it is prefix sum right. Here it is box count is left. Here it is box count right. Okay, as simple as that. Now the box count left of 0 index, I am just going to take in the string whatever is the value, take the int of that. Okay, for example, here if the value is 1, I'm going to take 1 in that, or the value is 0, I'm going to 0 in that. Okay, similarly here the last value, remember -1 in Python means the last value. Okay, the last value in the box count of right, I'm just going to take the integer of the value present in the box count of -1. Okay, that is this particular string, whatever is the value, the last value, take convert to int and take it. Okay, as simple as that. Now I'm going to start this. So if you see here, what I'm doing, box count left of I is equal to box count left of I minus 1 plus int of box of I. Okay, that is box of whatever is the value, take int of that and take the value from the box count left of I minus 1, add both of them and store it in box count left of I. Okay, same case we have to do. Okay, yeah. Okay, let me show the left first, then we'll go to the right. Same thing here. If you see, now coming to prefix sum left of I, prefix sum left of I is equal to box count left of I minus 1 plus prefix sum left of I minus 1. So both the values of I minus 1 I'm taking for both the arrays. I'm going to add them and get the value of I. Okay, as simple as that. Same is the case for the left. So here we saw all the left. Now we're going to see all the rights. So see here, the box count right of I is equal to box count right of I plus 1 plus int boxes of I. Okay, you have to just compare it to this. Here it is I minus 1, so here we're having I plus 1. Okay, similarly, the prefix sum right of I is equal to box count right of I plus 1 plus prefix sum right of I plus 1. So exactly like wherever the minus ones were in, we have to replace them with I plus 1. Okay, as simple as that. So next what we are doing, we'll have to just add the prefix sum right of I plus the prefix sum left of I for each of the I, that is I from 0 to n minus 1, and we are going to get the answer. Okay, so this was the solution. If you talk about the space and time, you can see it is clearing all the test cases. If you talk about the space and time complexity of it, it is going to be O of n time and O of n space. So remember one thing here. Just I will go to the Java solution also, but before that, just I'm trying to show one seed to you. You'll have to germinate the whole plant out of it. Okay. See this case now. Okay, let me zoom in and I will show you. So this is how you have to move in in the interview also. See, first of all, like as you might be knowing, this question can be solved in O of n square brute force approach. I am leaving that for you to try. And one more thing is here now. For each I, if you see, for each I only need the value of I minus 1. Okay. I don't need the whole array as such. I only need the value of I minus 1. Okay. As simple as that. So in case of this also, this is the truth. And here let us see. For prefix sum of left of I also, we need only the I minus 1 values. Okay. The idea here is I'm trying to tell you why this solution can be reduced from a O of n to O of 1. That is O of constant. That is, if even see, we are not going to create array. Okay. Even without creating array, just by using some constants, how we can get the whole solution. So that is how I'm trying to give you the idea. So see here also I is only dependent on I minus 1. Okay. With both these arrays. So the idea here is, even if we take some constants, we will be able to get I. Okay. We have to just store the previous value of that constant in a, okay, of those values in a constant, and we can use them to get the ith value. Okay. Same is the case here also. For the ith value, I am dependent on I plus 1 value and ith value. See, box of is anyway given to you. Okay, you should not consider this. Okay, so here we are only dependent on I plus 1 value, and similarly the prefix right of I is equal to the box. Okay, here you also depend on I plus 1 value. So the idea here is this solution can be reduced to a O of constant solution in terms of space complexity. And I showed you how, because if you see, each of the i's are only dependent on, okay, I plus 1. Okay, and instead of calculating this whole part separately, you could have calculated here itself. Okay, because remember, for answer anyway you will have to create array. Okay, no doubt in that. So that we are not including in our complexity, just remember that part. So in order to reduce that solution into a constant space complexity, you should not count the space used for generating the answer, because the answer has to be an array. So for that purpose we are returning it, but that should not be part of our space complexity. Okay, so we have to make best use of this array, because in this array itself we have to do all the calculation. That is, if you want to store something, that is, instead of calculating like this, what you can do is store it here directly. Okay, store it here directly, as simple as that. Okay, that's what I would tell you. Okay, as simple as that. So in order, if we do that, we will not need these 4 arrays as such. We will be just needing the last answer array, and with that we will be able to get all the answers. So this I leave for you as exercise, because if I do that here, the thing is, it will become very unreadable code. Okay, so I will not be able to explain you very keenly. For that reason, I am leaving it on you. I explained everything here. Now I'm leaving it on you how to make it as a O of 1 solution. Ideas I have already given you. Each of these things you have to reduce with a constant. Okay, you'll have to replace them with a constant. Okay, as simple as that. And now coming to the Java solution for it. See here, this is the Java solution. So yeah, I'm creating 4 arrays. Okay, prefix sum left, prefix sum right, boxes count left, and boxes count right. Okay, so I'm creating them. All the length is going to be n. Okay, now you can have also done like this: arrays dot fill, then the array name and the value. Initial value will be 0, but since integer array will always have the initial value 0, I am not doing that, since that's why I've commented out. But I just wanted to teach you, if you need something else other than 0, that should be filled in the array before you start your calculations, you could have used arrays dot fill. Okay, as simple as that. Next, I'm creating answer array. Here I'm creating the answer array directly. Here I did not create any answer array, but I'm returning here. I'm creating it dynamically and returning out. Okay, in Java I did not do that. I created an answer array in the starting itself. Okay. Next, rest of the solution is exactly same as that of the Python solution. So see it here. So here, if you see, yeah, if you see, we have to just do int of the character. Okay, here in Java, what you have to do, we have to do character dot get numeric value of the character. Okay, in order to get the character, what you do, you have to use the caret function and the index, and after that you have to use the get numeric value function. Okay, next, now we are populating each one of them. So you will see 4 for loops here. Okay, each one of them is going to populate one of the arrays. Okay, here we are populating box left of I. Here we are taking help of that and using the calculating the prefix sum of I. Here if you see, we are using the box left of I, which we calculated here. Okay, next we are populating the box count of right, and here we are using that to populate the prefix sum right. Okay, now using this prefix sum right, okay, using these 2 arrays basically, and now I'm going to create the answer. So if you see, this is the final answer. Answer is equal to prefix sum left of I plus prefix sum right of I. Okay, and then we're getting the answer. Let me quickly run this and show it to you. As you can see, this is clearing all the test cases, and I've already segmented this solution. I will give both the solution in the comment section, and your task will be to Okay, see, because I don't want to make this video very longer one, and since I've done the similar kind of question a long time before, so I don't want to repeat the same thing again. So this I'm leaving it on you as a challenge. That see, now you have very clear concept, because I explained you everything how this thing is working. Now the challenge for you is how to convert this O of n solution to a O of 1 solution in terms of space complexity. Okay, so instead of using this four arrays, you should use some number of constants, that is some number of variables, that is fine, but you will have to reduce this whole solution to a O of constant space solution. Okay, so yep, friend, that was all for this particular video. If you learn anything from this kind of videos, please do subscribe to the channel. This really gives us a lot of motivation to continue further. And this is the first time I've given you homework that you will have to remove all these four arrays, and you will have to, yeah, make it as O of an O of constant solution, because the idea here is each I is dependent only on one of the values, that is I plus one value or I minus one value. Okay, so that is the reason why it could be made into a constant solution. But since if I do that, that code will be kind of unreadable for you. That's why I want you to do that and paste it in the comment section. If you have any doubts, you can reach out to me. I can show you the solution at last. Okay, but I want you to do that first. Okay, so yeah, friend, that was all for this video. Please subscribe to the channel. This really gives a lot of motivation to continue further, and see you tomorrow. This was a very good question. I definitely recommend you to give a try. That's why I did not give you the brute force approach, which is going to be open score approach. I did not give you that, because that you can see anywhere, because that is very, very easy. Okay, I expect you to do that on your own. And coming to the optimal solution, I have given you the whole idea of how this works. My my aim was to teach you the prefix sum idea here. That's why I spent this much time, this much print statements and all that, to get you to the depth of it. Okay, now it's up to you to build the next optimal solution, which is going to be O of constant space complexity solution. The current solution that I'm showing you is O of n time and O of n space. Okay, so yeah, friends, see you tomorrow. Thanks a lot. Bye.